As you look at any algebraic system and you're doing something by algebra here, what you want to do is you want to go and look and see, does elimination or does substitution work better for me here? Well, this one is set up really nice for elimination. I mean, if you look at this, we're going to see that we don't need to do a lot of work to this problem to get the problem to start working. Literally, if you just add them together, you're going to get yourself 3x squared equals 12, which is really nice. Then when you divide by 3 to both sides, you get x squared equals 4. So then the key is you realizing that there's plus or minus 2 when you take the square root of both sides. All right, well, putting this all together, though, what does that mean? That means if you have a 2 or you have a negative 2, you're going to get answers coming out of here, okay? So now, technically, you need to put them into both of them, but I'm going to show you exactly how you can come up with the rest of the answers. So let's just plug it up. There's more positive signs in the top one. So let's go 2 times 2 squared plus y squared equal to 24. All right, so 2 times 2 squared, we got a 4 times 2, we have an 8 plus y squared equals 24. And then that's going to give us y squared equals 16. And these numbers are working out really nice. That means y is equal to plus or minus 4. So here's the kicker. What did I put in? I put in a 2. So when I put in a 2, I got a 4. Or when I put in a 2, I got a negative 4. So it actually creates another ordered pair. Likewise now, if I were to take and put in the negative 2, that's not going to change anything. You're still going to get plus or minus 4. So when I put in negative 2, I'll get 4. But when I put in negative 2, I also get negative 4. Okay, so this video is to try to get you to understand the process of how we go about these. I highly suggest you go back and you look at your review problems, you look at the practice problems where sometimes this gets tricky just because it doesn't come out to a nice number here. I mean, if this problem right here turned and at the end you got x squared equals 8, well then when you do the square root of both sides, you would get x equals plus or minus 2 root 2. Well then that would be more complicated to plug in and find the other values, but the process is the same. So don't let the radicals throw you off if that's just what's catching you. Hopefully the process is making sense. Okay, moving along here to problem 5. Okay, so now all we have to do is graph and shade, see where they cross. So that first one there is a circle, set up perfectly as a circle of a radius of 7. So I'm going to try my best here. 10, 9, 8, 7, 10, 9, 8, 7. The center was at 0, 0. Okay, and I'm going to make, wow, this is not perfect at all, but there's my circle. But the kicker is here, if it says less than or equal to, that means below a line, right? Less than is below a line. In a circle, it means inside the circle. But if you ever have trouble, you can always shade the truth. So I'm going to test 0, 0. 0, 0 is right here. It takes literally 30 seconds or less to test. If I plug that in, I get 0 plus 0 less than or equal to 49. This is a true statement. So since this was true, that means I have to shade the inside of that circle. Okay, so the whole inside because the origin tested true. If the origin was false, I would shade outside the circle. You only have to test one point. It's very straightforward and simple to do. All right, then this is a line, so I'm going to subtract x from both sides and get this set up in slope-intercept form. So negative 3y is greater than or equal to negative x plus 6. Then I'm going to divide everything by negative 3. And then I need to remember not to flip out, just to flip the sign. So then I take this and I flip the sign, and I get 1/3 x minus 2. So when I go graph this right now, down 2, there it is, up 1 over 1, 2, 3, up 1 over 1, 2, 3. Okay, so this isn't the greatest graph job, but there's my line. And I want to do above or below. Well, the less than means I'm going to shade below. But just to show you again, if I test 0, 0, that'd be a 0 here. This would cancel. I get 0 less than or equal to negative 2. That's not true. That's a false statement. So this point right here is false. That means I shade the other side of the line. So I shade below the line. Well, here's the deal, and I'll try to make this nice and solid here. Let's see how my skills are. This is the area right in here that would, wow, that looks good. Okay, that's the answer because inside the circle and below the line, that's exactly where we should be. Okay, last one here. this is, hopefully you got these straightforward skills, but that is an ellipse. It's set up perfect for an ellipse with an A value of 10. Oh wow, so we gotta go all the way over here, A value of 10. Really gonna test my skills here. And then a B value of 4. 1, 2, 3, 4. 1, 2, 3, 4. There we go. And we are going to be graphing. That wasn't bad. I'll take it. Okay, greater than, so we're going to be outside. So we got to shade outside the ellipse. Now again, if you don't get that, I'm going to test 0, 0. Won't take long. 0 squared over 100 plus 0 is 0. I'm going to get 0 greater than or equal to 1. Is that true? Nope, it's false. So that means I have to shade everything that's outside of the ellipse. Okay, then what's this shape right here? Oh, just another line? No, that's actually a parabola. And it's a parabola that's the one we're used to seeing. It's nice and normal. Okay, so if it's nice and normal, that means the vertex is at -5, -1. But remember, we got to flip this downward because of the negative out front. All right, so -5, -1. So here we go, -5, 1, 2, 3, 4, 5, -1, and over 1 down. So okay, so we're gonna be like this. Now, if you're like, oh man, I don't know our shade, here it is. You don't have to guess. Test a point. We have the origin right here. If I test the origin and it's true, that means I shade all this stuff that the origin is in for that region. If it's false, I gotta shade inside here. So let's see what it is when I plug it in. Plug in the origin, I would get 0 greater than or equal to, and that would be the opposite of 0 plus 5, quantity squared, plus 1. So 0 greater than or equal to, okay, so this would be 5 squared, which is 25. So -25 plus 1, -24. So is 0 greater than or equal to -24? True or false? That's a true statement. So what do we need to shade? We need to shade everything that is outside of the ellipse, but also outside of the parabola. So, all right, so it'll be everything outside. If we're just looking red right now, we want to shade all of this, right? Anything outside. Now, if that looks crazy, that's because it is. So let's clear up our answer. Where do these intersect? Anything that's outside the ellipse and also outside the parabola. So that would be like down to here. It's kind of an ugly one. Definitely going to admit that. All right, so then that's the way this one would be. Now, I can make this a lot easier by switching some inequality signs around, but basically we can't shade inside here and we can't shade inside there for the system. Okay? I highly suggest you going back and just looking through the review problems, get some more practice.